Hello, and thank you for joining us today for the download, HPCC Systems Community Tech Talks. These are Tech Talks for the HPCC Systems community by the community. As we get started today, I'd like to remind you of a few housekeeping rules. So first, please do share. Let others know that you're here and use our hashtag HPCC Systems Tech Talks. Please also ask questions. We definitely value your questions, and we will answer as many of them as we possibly can after each speaker. We also encourage you to provide feedback. The feedback you provide helps us to get better. So please do rate us before you leave today and visit our blog afterwards for more information about the event. And if you'd like to be one of our featured speakers, please let us know. Reach out to us at techtalks@hpccsystems.com, and we would definitely welcome your participation. At this point, I'm going to hand the speaker over to Flavio.
Thank you very much, Jessica. And it is great to be here again with everyone attending this webinar. We have a number of very exciting news, things that will happen quite soon, like, for example, the HPCC Systems Summit. But I don't want to get ahead of me. So the first thing I want to announce, as you can see in the slide, is the fact that we have just released our HPCC Systems version 6.4. This gold release was just posted a couple of days ago, so it's very fresh. It has a number of exciting features over the 6.2 series. By the way, the latest and greatest 6.2 release has been done as well. But in this particular case, there are things like, for example, new ML bundles that support logistic regression and linear regression, which are quite useful for those that need some basic machine learning models to apply for classifiers and regression. We have now additional options in ECLIDE that provide better colorization and icons, which they are visually appealing, but also help you better deal with your code in a way that it's far more pleasant at the eye. We do have now also better embedded language support for AWS plugins and certainly for Python. And I hope you are already using Dynamic ESDL. But if you are not using Dynamic ESDL, I highly recommend it. When you use Dynamic ESDL, you can just code your Roxy queries, and they will automatically and almost automatically publish all of your code directly to ESP to have the fully fledged ESP SOAP interface and RESTful interfaces built for you without any additional work. And certainly, last but not least, we are releasing the new version of WSSQL, and this can help you in a number of areas, not just into direct use of SQL on HPCC, but also support, for example, our integration with RIDE, which also uses WSSQL, and certainly the WS Client 1.2, which are about to be released right now. Now, as I mentioned initially, we have our HPCC Summit. This community day will happen very soon. We have a poster competition that will be done on October 3rd, and the actual community day will happen on October 4th on 2017. So it's just around the corner. Now, very important this year, we have a couple of things that are worth of mentioning. One of them, we have decided to open this community day to the public. So anyone can join us there. We will have all of the details for this community day in the HPCC Summit 2017 link in our HPCC Systems portal. So please go to the portal, take a look there, and invite your friends and relatives to come. And the other important thing is that we have a number of sponsors that are helping us push this event even beyond the boundaries that we normally have. So I really thank you, Cognizant and Infosys and Datum, for your very valuable sponsorship and for helping us to make this year a success, even a bigger success than the previous years. So keep in mind this HPCC Summit Community Day that is happening very soon. Go to the link that is posted right now on the screen and register yourself if you haven't done it. And if you have friends and family or whoever you want to attend, please let them know as well. Now, very important, we have also, just before that community day on October 3rd, we will have a pre-event workshop. And I have it on the screen. This will happen on October 3rd too, the same day that we do the poster presentations. We will have a full day workshop that will go through a very appealing title, which is Mastering Your Big Data with ECL. This workshop will be presented by one of our expert trainers, and it will go through all of the basic topics of about getting data into Hpcc, all of the data transformation and loading and extraction, but also it will go through building a search engine on Hpcc and even writing and publishing your Roxy queries, for which you will have the ability to try dynamic ESDL too. So it is going to be a great workshop. It's going to be a very good way to get people started in Hpcc, and even those that are already started on coding might find quite a few things that are very valuable throughout that day. It is a great opportunity to find other like-minded people as well and connect with them throughout the workshop, and also to hear some of the words of wisdom from our lead trainers. So this is a great opportunity for you. If you would like to get there or invite others, please do so. Again, the link is posted in the screen right now to register. If you want to register, please do so as soon as possible, because, of course, the seats are going to be going very quickly, and if you don't have a seat because you just went there late, you will be very sorry. So please go to that link and register as soon as you can if you think this is going to be a good opportunity for you to, again, find other like-minded people, learn more about Hpcc and ECL, and have some even practical experience on coding some of these things by yourself. Now, an important topic as well is the agenda for the community day. It is on the screen right now. As you can see, we have a very information-packed day. We have plenty of great segments throughout the day, and all I have right now is the segments listed. I don't have every one of the talks in detail. There are several talks in each one of these segments, but it is important to mention that we will have a number of community leaders, people that are working on Hpcc day in, day out, and companies that are using Hpcc, presenting what they do and how they achieve their goals and succeed in their own enterprises. And we will have also an interesting panel throughout that day as well, which will also include some of the leaders in the community throughout the academia area. And I think everyone will find this entire day very fulfilling. I know how we have done this the past years. Every year we try to push it up a notch in quality and content and interesting topics to cover, and I think we have done it again. So please take a look at what we have right now in the agenda. All of this is going to be posted in the main link in the portal, and please register to the summit as soon as you can so we can reserve your spot. Again, if you just wait until the last minute and you miss the opportunity, you will be sorry as well. And just without more preamble, let's go to the main day then. Today, what do we have for you? And we have a great set of talks. All of these talks are about from and about people that are doing their Hpcc internships this year. And we have Lorraine Chapman, who will be coordinating, and you know Lorraine from previous talks, but if you don't, she is a lead coordinator of all of our Hpcc Systems internship program. and she will be introducing each one of these speakers. And just to give you a little teaser there, we have Lily, who is here with from Clemson University, and she's been doing some great work in optimizing clustering algorithm. I don't want to say more about that. You will see it in a few minutes. We have also George, who is from NC State, and he is doing very interesting work. You will also hear about his work, which is very cool. He's been doing this for quite a few months, even before the internship, but now he's even more entrenched into this research. And last but not least, you probably know Vivek from past appearances, but Vivek, also from NC State, will be talking about his current work. And he has been doing work in many different areas, so and he's been a recurring personality in the community, but it will be great to hear again what he's doing right now and as part of his internship. So no more, without any more preamble, and just looking into getting all of this content delivered to us, I'll just let Lorraine get the starting point for this discussion. Lorraine, the floor is yours.
Thanks, Flavio. Just going to forward the slide on. There we go. Well, before we meet the two students who are going to tell us about the projects they're working on, I'm going to share some details with you about our intern program for listeners who may be a student or may know someone who might be interested in completing an internship with us in the future. In the interest of time, because I really want to get to the meat of this tech talk and get to the speakers, I'm not going to be able to cover everything here. So the links that you can see on the screen now will take you to more information that you can read about, all to do with the intern program, such as the various blogs that are on our website and information that we have on our student wiki. And we'll also display this at the end for those of you who might not have time to note down this information now. So the intern program runs every year, and application is by project proposal. Students choose a project from our list, or they can suggest a project of their own. But if they do that, then it must leverage Hpcc systems and be of benefit to our open source community. The proposal period opens at the end of September and closes in March. Good proposals include a lot of detail. What we're looking for is information that helps us to assess how students will complete the task required. And so we also need a timeline from students showing what they intend to complete for each week of their internship. So it is quite detailed and it is quite a challenge. However, each project also has a mentor, and the mentors are available during the proposal period to discuss ideas with students who show an interest in the projects they're mentoring. And they can answer questions also during the proposal period. And very often they ask a few questions themselves to students to help them with their thought processes as they prepare their proposal. And this invariably means a better proposal comes in the end. The project mentors are also there to guide and support students throughout the internship itself, should they be awarded a place. It's a paid internship program. It lasts for 12 weeks. It's also a global program. Our interns have worked remotely from India, Ireland, as well as in the USA. Although US-based students may be able to take advantage of working in one of our LexisNexis office locations, and in fact, all three of the students who are speaking today have opted to do that. But we also do have a student this year who's working from India remotely, although he can't be with us today. Most students start work towards the middle of May and finish towards the middle of August. but we can be flexible to fit in with the difference in semester dates in different countries. And we also welcome students from right across the academic spectrum, from high school students through to undergraduates, masters, and PhD students. The internship program provides opportunities for students interested in coding that want to immerse themselves in a real-world development environment. They use the same tools, they follow the same code check-in and review process as all the other developers on the team, and actually we do consider them to be part of the team during this internship. So it's a robust and challenging program, and today you're going to meet 3 students who have met this challenge head-on. They've almost completed their internships now and have made some great progress on their projects, and they're going to demonstrate that to you today. So before I introduce our first presenter, I'm just going to quickly hand back to Jessica in case there's any Q&A. So over to you, Jessica.
All right. Thank you, Lorraine. Fortunately, no questions have come in yet, but I would encourage everyone throughout the presentation, if you have questions about what's being presented, or if you have questions for Lorraine about the intern program, please do feel free to submit those. All right. Lorraine, I'd like to just turn it over to you quickly to introduce our first intern candidate.
Just forward the screen.
All right.
The lilies, there we go. So when evaluating proposals from students, we're not just looking at their technical ability. The content and the effort that they put into them tells us other things we want to know, such as, does the student give the impression they're highly motivated and hardworking, eager to contribute and willing to learn? And our first speaker today has all of these qualities in abundance. Her mentor for the last 2 years, Edin Muhammadic, has often commented about this and has really enjoyed working with her. As you can see, she's a PhD student in computer science studying at Clemson. Last year, she joined the team to implement the yin-yang k-means machine learning algorithm in ECL. And this year, she has returned to build on this work by optimizing this algorithm for large clusters. So without further ado, Lily, I'm going to hand over to you.
Thank you, Lorraine. Thank you for letting me introduce my intern project and experience in this tech talk. I have been working on the yin-yang k-means clustering algorithm in Hpcc system since last summer. So you may be wondering, what is clustering? Here is one example. So recently, LinkedIn have open public computation for mining their customer data. So how they can mine big data to find the potential elusive hubs between your professional worlds. Now here's one example. As you can see in the picture, clustering algorithms such as yin-yang k-means can automatically categorize a customer's professional network into groups, such as previous employer, LinkedIn, college classmates from Kinelon, or industries you have been working in. So they can help us to see the way all your connections are related to each other. Even be able to identify the elusive hubs between our professional worlds. It looks pretty cool and also helpful for us to think about what we can do to extend our professional network for a better job or for a better future career. Another example is doing pricing segmentation. So for business users, yin-yang k-means can help retailers to segment the customers based on customer spend patterns and understand the price sensitivity of the customers. Some of the segmentation variables considered such as total spend, value of discounts, percentage of discounts across transactions, number of items bought on discount. So based on all of this information, we're combining the data and find the discount variations of the customers. Another example is some organizations may think if they have a real loyal customer, so this can also be mining by clustering algorithms to finding the loyal customers. Some of the common expectations for a loyal customer including frequent spend, higher ticket size, or diversified spend. So like Young K-means can help us, the retailers, understand customers by clustering them into different dimensions, such as customers who love the store, customers who just occasionally came here, or customers who just regularly come here for shopping. So this helps them to improve the business rate, also save the advertisement cost. So because of the power of clustering algorithms, we already have developed a lot of powerful algorithms in Hpcc systems, such as K-means, different trees, LDA. Oh, I'm sorry, pop up the list. Yeah, so my intern project in the last summer is to implementing Young K-means into our machine learning library. And this summer, I'm working on improving the performance of Young K-means. So Young K-means is a drop-in replacement of the standard K-means. It can achieve 2 times to an order of magnitude faster than standard K-means. Also, Young K-means can guarantee the exact same result as a standard K-means. That's why we're trying to implement Young K-means in our system. Because Young K-means is based on the standard K-means, I will first briefly introduce the function how K-means works in our system. So K-means is an iterative algorithm. It first initializes the number of the clusters in the system. So here is the process how K-means works. First, we define the number of clusters we want to have in the data set, and then we randomly assign the centroids. And then we're going to the looping function. The looping including 2 parts. One is assignment part, one is update step. So it's looping until the centroids don't drift anymore, or we can see the centroids don't move their position anymore. Then we can output the results, the clusters. Here is an example which is more clear to understand the process. So we first choose the number K to be the cluster number in the data set. So here we choose 3 cluster centroids. I'm sorry. Yeah, I'm sorry. So in the initialization, we initialize the number of K, and then we assign a centroid ABC. And then in the assignment step, we calculate the distances between each data point to each centroid, and assign the closest one to the closest centroid. So for example, we calculate the distances from Z1 to each centroid ABC, and then we find out centroid A is the closest one. So we assign Z1 to centroid A. And we do the same calculation for each centroid B and C, and also all the points Z1 to Z9. So the result is we calculate all the distances from each point to each centroid. And based on the assignments, we now can recalculate the new distance of each centroid based on the updated equation. The updated equation is based on just the average, take the average of the distances of all the data belong to one centroid. So here is the equation. It's based on the relocate of the centroids. The centroids won't move or just within the certain drift. We can see the looping function has been converged. Then we output the results. If the looping function still not converged, that means the centroid is still drifting or moving. Then we still go back to assignment step, and then we looping from assignment step to update step until the looping function converged. So in-year K-means improve the K-means by reducing the calculation of all the distances. So in-year K-means, it first still the same. We find the number of K in the cluster in the data, and then instead of assign the K centroids, it first grouping the centroids into groups, and then based on the group information, it will go into the loop again, but this time the assignment step have two new components, the group filter and the local filter. They are the key components to help the in-year K-means in assignment step to filter out the distance calculation. And then they go into the update step. The same as K-means, it will looping through the update step and assignment step until the centroids don't drift anymore. And then output the number, the result of the clusters. So here is one example. We can see in the picture, in-year K-means first the grouping of the centroids into groups, like in the circles. And they have data points C1, C2, and C3 at the beginning. And then we apply the group filter and local filter sequentially to filter out the unnecessary data points for calculation. More specifically, we have C1, C2, C3, and they first go through the group filter, and then the group filter first filter out the group of centroids. So then we can see after the group filter, we have only 3 groups left. I'm sorry. Please let me to turn back to the in-year K-means. Yeah, so back to the topic, so in k-means using the diamond step and the group filter and local filter remove the unnecessary calculation of the distances between data point and centroids. And one example is we have Z1, Z2, and Z3, and they both have, all of them have 3 groups of centroids. And after the group filter, there's only 1 group of centroids left for Z1, and there's nothing left for Z2. And there's only 2 groups of centroids left for Z3. So that means for Z2, there's nothing happened for Z2 to calculate the distances anymore because group filter has already been filtered out all the centroids for it. So based on this, we can see in k-means reduce the calculation dramatically using the group filter and local filter. So based on this understanding of in k-means, I implemented in k-means algorithm in last summer intern program. And after the implementation, this summer I'm working on optimizing the implementation. How to optimize the implementation? One step is to do the performance analysis in ECL Watch. So one example is in ECL Watch, there is a timer, times, and graph tabs can help me to see which part of the code costs the most of time. So here, for example, the times tab in ECL Watch, we can sorting the timings. And then we see on top of it is the graph 2, subgraph 344 is the most time-consuming one. So you click Innate and go into Next tab to see the detail of subgraph 344. Then we go into the graph 2, ID 344 subtab. We can see in this list there is a lot of activities, but the most time-consuming one is activity 499, based on the time execution time. So we click on the sort, we go into the graph tabs. So the graph analysis is very important in performance analysis because in graph tab we can see the whole data flow of the whole algorithm. Here we care about the sort function here in the middle of the data flow because it's the most time-consuming one. So we click on the sort, then we can see there is a property tab in the right side. It's called 499, and we can see which line is the code located in the ECL script. And here we can see it's located in line 196. But when we go back to check in the script, we found out it's not inside k-means function, but it's a helper function. So the way we're tracing back to the code inside k-means function is to go back to 2 layers. And we found out there is a read local data in the data flow. And we click on the read local data function. We see the code is sitting on the line 624. And then we go back to the ECL script in ECL IDE, and we found out, oh yeah, this code is sitting on line 624, and it's inside k-means function, and that is exact code called the helper function. So that's where we can go into to inspect why sorting function costs so much time. And then we transfer from the graph analysis to code analysis. So finally, we found out in ECL IDE's line 624, the sorting function inside the dedupe costs the most time. And then I will optimize the code in mainly 3 ways. One of the optimization I can do is I optimize the sequential algorithm by recognizing the undistributable or insufficient component in the distributed manner. So some code may be working well when we program it in Java or sequential programming environment, but sometimes it's not that efficient or is indistributable in distributed environment. So we have to change the original algorithm to fit into our system. Another way is I add a global filter and combine with the group filter to avoid the Mathew communication between the nodes. And another way I did it was to distribute the data set or record set smartly to avoid Mathew communication. And in the Intern Program, after the implementation and optimization, I need to do code check-in or code review. In this process, I have my own GitHub account, and our company have official Hpcc Systems GitHub account, so I will submit my code to the official account by submitting my pull request. And our system has management, our official GitHub account management by machine learning and ECL experts. After they review my code, they will give my comments in GitHub and help me to improve my code. And at the end, I will submit my pull request to Hpcc Systems. So in general, intern experience for me in the past 2 summer intern program is very awesome. I have very good experience, and I think it's mainly because I have a good communication opportunities with my mentor and my colleagues. We have instant message like Skype. We have just call each other. So I think the intern program have very good communication schemas here. And also we have lots of ways to asking for help. For example, we have Hpcc System Forum. Here is 2 examples of my posts. So I post my post on the forum, and I got really fast reply from the top ECL experts in our company, like Woman and Taylor. And they are really helpful, and I solve my problem very fast. And also you can just ask your mentor and colleagues, but sometimes they may be busy or they're not there. So online resources are very important. And also interning here, I feel like the work and life balance is very good. There's on-campus gym, and yeah, and also company will bring us to brief games. It's pretty cool. Yeah, this is my general intern experience and my current project, and I want to use this opportunity to thank for my mentor Aiden, who always guided me and helped me, and also John Hall, for giving me tremendous help on my technical problems, and also Gavin and Jake and operation team always help me on my system problems. And also thank you, Lorraine and Ranu, and also Trish, organizing all the amazing events. And thank you for listening to my intern project. And if you have questions, I can answer the questions.
All right, Lily, thank you so much. So I'll give you a second to look at the questions that have come in from our audience. We've got 3 of them there. But I want to thank you so much for doing this presentation, and I know that we certainly have enjoyed having you here. All right, I'm going to go ahead and start with the first question. So should yin-yang provide equivalent results to standard k-means, or do you expect to be less accurate due to the optimization?
This is a very good question. I think for now, I'm still achieving the exact same result as standard k-means because I want to balance from the accuracy and the speed up. So if we achieve a higher speed up, maybe we have to sacrifice a little bit accuracy, but for now, in our system, we still achieve the exact same result as standard k-means.
All right, thank you. And here we've got a second question. What have been your greatest challenges when coding and optimizing this algorithm in ECL?
I think the biggest challenge for me is, last summer for me, is the learning curve is from learning ECL in the last summer. For this summer, I think the challenging is how to really understand the algorithm and to make the sequential algorithm working well in our Hpcc system. So I think for me in this summer is algorithm-wise problem make me feel more challenging than just coding in ECL.
Thank you so much, Lily. All right. Okay, so Lorraine, we have one additional question here. So which ones of these make yin-yang faster than standard k-means? A large number of points, a large number of dimensions, or a large number of centroids? And when I should prefer it over standard k-means?
So actually, it depends on the environment when you're using yin-yang k-means. So for the original yin-yang k-means in sequential environment, yin-yang k-means should be faster than standard k-means in all of these aspects. For example, the number of points, the number of dimensions, and also the number of centroids. Yin-yang k-means should outperform standard k-means in all of the 3 aspects. But when it came to the Hpcc system, it's different from the sequential programming environment. So it definitely, the more number of points you have, the yin-yang k-means will gain more advantages than standard k-means. And if you have a very large data set and a very large number of clusters or centroids, then I think that time is when we prefer to using yin-yang k-means rather than standard k-means.
All right, Lily, thank you so much. So at this point, I'm going to turn the presentation over to Lorraine to introduce George.
Thanks, Jessica. So earlier I mentioned some of the personal qualities that we are looking for in our students, but obviously we're also looking at their technical approach and their thought process. And I'm sure you can tell from Lily's presentation on implementing a machine learning algorithm that, a lot of the projects that we offer, particularly in that area, do require quite a lot of knowledge, which Lily has very impressively demonstrated. Our next speaker was quite happy to contact the project mentor of his gradient boosting trees project, John Holt, during the proposal period to discuss his ideas and seek answers to any questions he had before submitting his final proposal. And this is exactly what we want students to do, because we don't expect them to have all the answers. And since there will invariably be stumbling blocks along the way when implementing a project, it's always good to know that a student is prepared to be open and seek help when it is needed. Mathew's proposal was very well received when it appeared in my email earlier in the year. It demonstrated that he had a very clear idea of what he wanted to achieve and how he would achieve it. George is a first-year PhD student at North Carolina State University, again studying computer science. And since he started his internship, I've heard nothing but good things about his progress and the work he has done to complete this project. So now I'd like to hand over to George, who will present about implementing the gradient trees machine learning algorithm in ECL. So the floor is now yours, George.
Thank you, Lorraine. Hello, everybody. My name is George Mathew. I'm a first-year PhD student in computer science from North Carolina State University. I'm going to talk about my summer research or summer internship on gradient boosting trees. So, first up, the prime motivation behind something like gradient boosting trees is the statement: mistakes have the power to turn you into something better. That is, you take something really bad and you keep improving this really bad thing, and eventually it turns into gold. That's the entire motivation behind gradient boosting trees. On that note, a basic 101 on gradient boosting trees. The prime concept, as I said, is empowering the weak. You take a weak learner, a classifier, or a regressor, keep improving on its mistakes, and eventually it becomes a strong classifier. This can be applied on different learner types, be it regression, classification, or even ranking. The essential underlying concept behind gradient boosting is that it's a combination of gradient descent plus the standard boosting algorithm. And I am not saying this. This is an award-winning algorithm. Actually, it's won first place in Yahoo Learning to Rank Challenge in 2011, and it's also been a prominent part of the Kaggle competition, and it's been in the top 5%. At least a component of it has been used in the top 5 solutions in almost most of the proposed winners. So this is like, I'm just giving a basic math behind the gradient descent approach. Now we know that gradient descent is actually an incremental optimization technique where you try moving towards the solution with the greatest change. So consider that, say, X is your independent variables or what you have as your input, and Y is your dependent variables or what you have as your true output. And f of x is your estimation of the output, or you can say the predicted value. And you always know that the predicted value is not going to be exactly equivalent as your actual value. So you can say that y is equal to f of x plus some error gamma. Now, in an incremental approach, what you actually do is your solution in your next iteration is slightly better or worse than the solution in the previous iteration. So you can say that f of x in your i plus 1th iteration is f of x in your ith iteration plus some error between the iterations called gamma I. Now, this gamma I is actually nothing but the difference or the loss between your true value and predicted value in the ith iteration. That's y minus f1 of x, fi of x. And now the way you estimate your loss actually makes it into a gradient descent approach. Like, for example, based on the choice of your loss function, you can represent the value in your prediction in the I plus 1th iteration as your value in your ith iteration plus the derivative of your loss with respect to the derivative of with respect to your predicted value. Given that the basic math behind it, we can actually look at the high-level block diagram of gradient boosting trees. So as I said earlier, let's say X train is your input, what you're giving in, Y train is your output, what you're expecting. You send and just putting it out there, Y train is actually a set of continuous values. That is, those are values you're trying to estimate. So you send an X train and you build a decision tree. Let's assume it's called a black box called decision tree now. Decision tree with respect to your X train and Y train. You compute your error, that is your predicted value minus your true value. You retrain your decision tree now with this error, and you keep repeating this entire process, say m number of times, or till you realize that you don't need, till you realize that you're getting a convergent results, and you sum up all your values. So this essentially is your gradient boosting tree algorithm. So actually there are two black boxes in this case. One, what is a decision tree? Second, what is the error computation approach you would take in this aspect? So first, to study the decision tree, let's take a basic data set. So over here is a standard data set to understand a classification or a regression classification algorithm. So the objective here is, do you play golf or not play golf? Given the conditions, outlook, which can be sunny, overcast, or rainy, the temperature outside, hot, mild, cool, the humidity, normal or high, or the wind conditions, if it's a strong wind or a weak wind. And given all these conditions, you estimate if the conditions are optimum to play golf, that is yes or no. Now, what you actually do is you actually select an attribute to split. So based on this data, the best attribute to split would be outlook. And if the outlook is overcast, to decide you can go play. Whereas if the outlook is sunny, you look into the next attribute, humidity, and you see that if it's highly humid, you don't play. Whereas if it's normal, you play. Whereas if the outlook is rainy, you again look at humidity, and if the humidity is normal, you play. If it's really high, you then check the wind conditions. And if the wind is really strong, you don't play. Whereas if the wind is weak, you play. Now the question over here is, how did I actually decide which attributes do I split at? So there are numerous splitting criteria which have been proposed. So you select any splitting criteria such that you end up in leaves which are highly pure. What I mean is you end up in subnodes of the tree where there is a majority class, it contains only one class, or classes with very low impurity. So there are many splitting criteria have been proposed over the years. Two of the common ones are Gini, which is nothing but the sum squared probability of the majority class within a node. So you essentially try to maximize your Gini factor. Then entropy, that's the sum of probability and the log probability of the majority class again with the leaf. So entropy is not used directly, it's actually used in combination with something called information gain, where you actually see how much entropy you're gaining with respect to your base class. Finally, there's variance. So variance, this is actually a simple technique where you actually measure the variance within your class and the difference between the variance given a particular attribute. So you select an attribute, you compute the variance, and you estimate it with respect to the base variance that already existed, and you select that attribute which ensures you have the least least variance. Now moving forward, now we talked about the decision tree. Let's look at the error computation techniques used. So there are actually again multiple error computation techniques, but few standard ones are shown over here. There's absolute loss, which is nothing but the mod difference between your true value and your predicted value. There's a square loss with a square difference between your true value and predicted value. Now, the squared loss has a major drawback associated with it. As you can see, since you're squaring the error, it has a bad trait that it will optimize towards your outlier. Say if you have an outlier, your true value would be much larger, your error would be really large, and then essentially your loss would be even larger since you're squaring it. So to overcome this deficit, there's a proposed technique called the Huber loss. So what you actually do is that you set a threshold. So if your modulus of your error is lesser than this threshold, you take the error. But if the modulus of the error is greater than the threshold, you set it as the threshold multiplied by the sign of the direction of your error. So these are the loss functions associated with the decision tree. Now, in general, we have actually seen how the internal rubrics of a decision tree work. But as you can see, this would only work, the technique I discussed just now would only work for a regression problem. I cannot do this for a classification problem. Like for example, each time you're estimating the loss cannot be directly estimated for a classification problem because these are not real values. They would actually be ordinal values. So how would you actually extend this regression problem for a particular classification problem? So it's actually, this is a small extension. What you can do is you can convert the classifier into a regressor. So assume you have your output has say C classes, you split it into C regressors and you build a decision tree for each of the regressors independently, and you select that class which yields the decision tree with the maximum value. That is essentially you're selecting the class with the greatest probability, and that would be your prediction. And so you repeat the entire process for each regressor independently, and eventually you select that regressor, that class with the regressor associated with the highest probability, and that's your classification approach. So you can again plug this back into your gradient boosting framework. So you just replace the independent decision tree and the error module with a series of numerous decision trees equivalent to the number of classes in the framework, and you select that decision tree which yields the greatest probability. Now, this can be extended beyond an algorithm. As you can see, it contains many plug-and-play components, like for example, the decision tree I'm choosing or the error computation. A simple thing would be I can try to normalize the training input to ensure that the values lie between 0 and 1, probably yield better results. Or I can normalize the training input. So here, ensure that everything is in the same ballpark to ensure that the variance is uniform. This can be done. A much better thing to do would be you can actually replace your decision trees with different kind of regressors, like say a linear regression or support vector machine or random forest. You can, if your algorithm just has a learn, predict, and compute error, learn and predict method, this can be replaced into this particular framework. An alternative would also be to replace the error computation technique with any other error computation technique of your choice. So this now goes beyond the algorithm into a complete plug-and-play framework which can be used as per the developer's choice. So I've actually run this on a few data sets from the UCI machine learning repository. So the housing and servo data sets for regression. So here I'm trying to calculate the efficiency, the accuracy using RMSE, which is nothing but the root mean squared error of my prediction. So as you see here, I've used naive linear regression and naive decision tree, and I've also supercharged this linear regression and this decision tree using gradient boosting and shown the results. So now as you can see, the supercharged version using gradient boosting actually does better than the naive versions in both the cases. And for the housing data set, the gradient boosting tree gives the best gradient boosting decision tree gives you the best result. So similarly for the servo, you can actually see that naive linear regression does much better than naive decision tree. But if you supercharge linear regression using gradient boosting, you see that the results are good, but it's not much better compared to linear regression. Now the standout result is the next one, would actually see that if you supercharge decision tree using gradient boosting, you can see that the results improve by close to 40%. That's a significant rise in the performance of the decision tree in this case. So you can see that it again goes back to the initial premise that you keep iteratively improving a weak classifier and it eventually becomes a strong classifier. This can also works for classification. So for classification, again, I use two data sets, yeast and vehicle, both of them from UCI Urban repository, and UCI Urban repository, and the three measures I use to estimate the efficiency of the approach is precision, recall, and false alarm. Precision represents of all the values I'm predicting, how many of them are true. Recall represents of all the true values, how many I'm able to predict. And false alarm is the number of false misclassified values I'm actually predicting for. Now here you can see that again the gradient boosting approaches improve the naive approaches, but not as good compared to the regression approaches. I think it's more associated, in this case it's has to do more with the data set rather than the approach. So yeah, it essentially works for both classification and regression approaches. Yeah, moving on. Now this approach has got a bunch of pros and cons associated with it. First thing, the pro is like you can take a really dumb classifier like a decision stump and even optimize that and even iteratively improve that to become a strong classifier. Second, it works with less RAM. Now you see a weak class. Most of the RAM is consumed in optimizing in estimating the parameters of a classifier. Now, since the classifier is a very weak classifier, it does not consume much RAM, and eventually you can probably serialize multiple classifiers at the same time to ensure efficiency in terms of memory in that aspect. Second, the so the optimization technique, I mean the iterative improvement technique, does not introduce any new hyperparameters by itself. Probably the only hyperparameter introduced over here would be the number of iterations you would want to do before you stop. Hyperparameters has always been a challenge with machine learning algorithms. Like for example, if you just take random forest, for example, there's numerous parameters like the polling technique you would try to choose, or the splitting criteria of your tree, or number of trees you would want, etc. So there are numerous parameters associated with any machine learning algorithm, but you can avoid introducing any new parameters which needs to be tuned from using this technique. So the cons, now as you see, this is an iterative improvement technique. So as a result, you cannot parallelize it. So a previous iteration has to be run, and the results of the previous iteration has to be used to improve the next iteration. Hence, you cannot parallelize this. It has to be run serially, which automatically leads to the next con, which is runtime. So runtime, since if your weak classifier takes much time, if a weak classifier takes a long time to run, eventually if you're trying to supercharge it using gradient boosting, that would also take a long time to run. But you can fix this to a lesser extent by using early termination. So what I mean by early termination is that if you see that your results do not improve over a set of iterations, say X number of iterations, you can call it quits and you can give out your model. And finally, this is just a work in progress. I mean, I've implemented a great chunk of it, but still a lot to be done. Firstly, there is the classification approach which we had discussed earlier in the slide, where you split a classifier with n classes into n regressors, can be parallelized. And this, so essentially your classifier becomes as fast as your regressor. I'm currently working on this. In the plugin modules, we actually saw that we can actually introduce normalization in terms of your input and output. Similarly, you can also introduce standardization. Finally, this is just a library. This is just a module in the ECLML library. Eventually, my mentor also suggested that this can be made into a bundle, and I think that should be the ultimate goal of this project, and I think I'll work towards that. And again, I'm open for suggestions based on this. What do you think I can change in the approach? And well, that's about it from my presentation. Thank you. I'm open for questions.
All right, George, thank you so very much. I'll give you just a moment here to take a peek at the questions. It looks like we've got a few of them in there. All right, so we'll go with this first one. This is super cool, and it definitely is. When do we expect to get a bundle?
Okay, yeah, so I'm not really sure. I think once I complete all of this, if I have enough time within the end of my intern, before my internship finishes, I'll definitely make a bundle out of this thing. And yeah, that's eventually the plan. Else, I don't even mind, since it's an open source project, I don't even mind working off even if my internship is done independently to ensure that it comes out as a bundle.
All right, thank you. So here's another question. What would be the reason to select gradient boosting and a weak learner instead of a strong learner? Is it because there are less hyperparameters to deal with, or is there an entirely different reason?
Well, yeah, so I think the question has the answer within it. So first, it has less hyperparameters to deal with. And second, the idea is that a initial strong learner would require a lot of memory associated with it. Like, for example, if you have a decision tree with probably 1,000,000 rows and 1,000 attributes associated with it, this would contain a lot of memory, and probably all the parameters cannot be estimated for the decision tree. Rather, if you take a weak classifier like decision stump and then iterate it 1,000 times, it would consume less memory, probably a little more runtime, but you would never, I mean, you'll not encounter a memory overflow issue with respect to that. So if you can compromise between runtime and gain on memory, I think this would be a good approach to take.
Okay, great. And it looks like we have one last question. You're mostly talking about using gradient boosting with decision trees, but wouldn't it be better to just use random forests instead? Or should both be combined using gradient boosting with random forests?
Okay, so yeah, these are two different boosting techniques, gradient boosting and random forest. In random forest, I think what you actually do is you have multiple strong classifiers, and eventually you select the best class. You select your output value based on polling the results of all your independent classifiers. So this gradient random forest has a great advantage over gradient boosting that you can run it in parallel. But again, each classifier within your random forest is a strong classifier, so that would consume a lot of memory. But gradient boosting, each classifier is actually a weak classifier, so you can actually use, in some cases, you can actually use the gradient boosting technique where you try to prioritize memory. Again, you can plug in, as I said, gradient boosting is more than an algorithm, it's a framework, so you can replace the decision tree with a random forest to function exactly the same way you want. So you can supercharge your random forest with a gradient boosting technique as well. So you can reduce the number of trees in your random forest, but you can increase the number of iterations to do this.
All right. Thank you so much, George. This has been a wonderful presentation. At this point, I'm going to turn it over to Lorraine to introduce Vivek, our next speaker. Lorraine, you may be on mute.
Sorry, yes, I was. Can you hear me now?
We can, thank you.
That's good, thanks. So thanks, George, for that great presentation. So in 2016, we held our first technical poster presentation competition on Community Day at our annual Hpcc Summit last October. And as you've heard, we're running this competition again later this year. This competition is open to any student working on a project that leverages Hpcc systems in some way. Last year, entries were submitted from students connected to other projects supported by our academic program, as well as those involved in the Hpcc Systems Intern Program. And at this stage, I want to say how justifiably proud we are of all of our students, past and present, who make such a valuable contribution to the Hpcc Systems Open Source project. You can find out more about all the technical poster entries from last year on our wiki at wiki.hpccsystems.com. And now I'm thinking maybe you're wondering why I'm mentioning the poster competition at this point. Well, our next speaker is a returning student who was awarded a well-deserved second place prize in our 2016 competition for his poster, which, among other things, illustrated how he implemented a regression suite for the Hpcc Systems Machine Learning Library. Vivek now is a PhD student at North Carolina State University, studying computer science. As well as providing a challenge to students, we also want them to enjoy their intern experience, and we love it when they want to work with us again. So we're really happy that Vivek has rejoined the team again this summer. He worked with his mentor Dan Camper to produce a proposal focusing on allowing Spark users to use Hpcc systems as a data store, while also providing ECL programmers with the ability to access Spark algorithms. And I know there will be a number of people listening today who will be very interested to hear how he's been getting on with this project. So over to you, Vivek, to tell us how you've been doing.
Hi. So as Lorraine said, my name is Vivek Nair, and I'm a PhD student at North Carolina State University. And my project is called Spark Hpcc because it tries to connect these two systems. So let's look at my objectives are there are two objectives to these projects. So one is we want to make sure that we can run a Spark program and use data from Hpcc systems. And the next one is to run Spark programs as a subroutine from ECL. That means there would be a a function which you can call and pass in a Spark code, and it will return the output. What that helps people is they don't now have to download data from the Hpcc cluster and then run Spark algorithms on it and then upload the data back to Hpcc cluster to work on them. So what we wanted to do was to remove the time sink and seamlessly integrate these two systems. So as we see, the other part of the objective that we had, we wanted to build a general solution so that it's just not Spark specific, but it works with any application, and like an analyst could use it to quickly explore the data. The words that you see, which is highlighted in like a color, are basically the terms that we would see throughout the presentation, and the technologies that we used is we built something called as Hpcc Fuse-J, which is a Fuse plugin for Hpcc. What that does is, using Hpcc Fuse-J, we can mount an Hpcc cluster as a local file system and can run on any platform. And this basically takes care of the data flow between Hpcc and any third-party application, and in this case it's Spark. And to submit Spark jobs, we leverage Apache Livy, which uses a REST API to interact with the Spark cluster. All right. And this is like the brief agenda. We start with the motivation, quickly introduce the solution, discuss the design we use to solve the two scenarios, and then we have a small demonstration where I show how the solution works, and we follow it with the future work. All right, so let's look at the motivation. Okay, all right. So currently the data movement between Hpcc and Spark is not very smooth, and it requires manual downloading of data, which is a pain point for many developers. Our objective was to build a bridge between these two systems that can solve the problem of data movement. And as I said, we wanted the solution to be general so that it can be used with other solutions like Python, R, or Spark. So let's talk about Spark Hpcc. Throughout this presentation, whenever you see a dotted line, it essentially means that towards the left of the dotted line, it will be Spark, and towards the right would be Hpcc. As I said, Hpcc Fuse-J controls the data flow between the Hpcc and the Spark world, and Hpcc Fuse-J what it essentially does is it essentially converts all the files and commands to a web service call and returns and contacts the Hpcc cluster and comes back with the data. And for the demonstration, so we would be talking about Spark Shell, which would be using to run Spark jobs, and we would talk about ECL IDE because that's what we use to run our ECL programs. So our first objective is to run Spark programs with the data stored in the Hpcc system, and the other way around as well, to use Spark programs as an ECL subroutine. And we wanted to use other applications, and we have tested this on like a terminal, which we would see in the demonstration. We also use it with LibreOffice, Meld, and Python. So we can actually run like any algorithm from scikit-learn and use the data from the Hpcc and run it on the local machine. Right. So for the design, so now let's look at the design of the solution. Like before, we have two worlds with Spark and Hpcc, and before we start, we have to make sure that Spark knows where Hpcc Fuse-J is. So Hpcc Fuse-J is nothing but a Python program which acts like an interpreter between file system calls and the web service routines. So we mount, so this basically mounts it as a local drive. So we start the Python program by calling pass through Hpcc py, which is the main file of the project, and then we pass in the Hpcc cluster IP followed by the port number, and we also say what's the local mount point, which in this case is git/mount_point2. And after which we can run the Spark program and treat the Hpcc as a local file. So we look at the program. So what we see here is this is an exactly a Python program. It's an example code from PySpark, and what we only did was we changed the data path. So we changed it to like an Hpcc mount point, it's like a macro, and then we say that we are using regression medium bike sharing data set, and then that reads the file and it runs a linear regression algorithm on it. All right. So let's talk about how do we connect ECL with the Spark world. So like before, the Spark is on the left side of the figure and the Hpcc on the right side. The Hpcc here again starts with mounting the Hpcc fuse J on the Spark cluster. And then we submit an ECL job using ECL IDE. And we use Livy to submit the Spark job to the Spark cluster, after which we poll just to make sure that, check the status of the job. After which once the job is finished, we could essentially return the results to Hpcc. Let's look at the Python program. The ECL program. So if you look at line 25, it shows a PySpark code, to be specific, which reads a file from a locally mounted directory and counts the number of records or rows in it. Now if we look at line 26, now we are actually passing the IP of the Spark cluster along with the code to an embedded Python function which submits the Spark code, which you would see in line 13. That's how we submit the Spark code. And then we poll it until the state of the job is ideal. And we could see it from line 15 through line 18. The code then retrieves the results in line 20 and returns the results. So if you look at it, all of the run command is a boilerplate and doesn't need to change with programs. However, the only thing that we should be concerned about is how we represent the PySpark code in line 25, and we need to be careful about the indentations and things like that. All right. So let's start with the demonstration. So before we start the demonstration, for this demo, so this is like I have two VMs, one which runs Hpcc and the other which runs Spark. So first of all, I'll demonstrate running the Spark with Hpcc and then demonstrate how to use the Spark with Hpcc data. All right. So, and let's see if we can. Jessica, can you share this? Can you play the video? All right. So what we are looking at is the Spark VM, and from Spark VM we are connecting to the Hpcc cluster. And what we see here is there are two folders in the Hpcc, which is called raw and Thor, and the Thor has few files in it which we would be trying to access. So here we have like three terminals. We have Fuse, localhost, and Spark terminal, which we would be running Spark. And if we look at the Fuse terminal, this basically shows that this is a GitHub project which is publicly available, so go try and use it. And then we start the Python program by running the pass-through_Hpcc py with the IP of the Hpcc cluster, or VM in this case, followed by the port number, and the local mount point, which is it's called mount point. After which we can see that we can try to see if we can access the cluster. So we change directory to mount point, which is our local mount directory. We would see two directories, which is raw and Thor, as we see in the ECL watch. We change directory to Thor, and now we see files in Thor. So there were like 6 files in Thor, and that's what we see here. And we can also try to view the content of one of the files, which is like clustering, medium, keg, for example, and head returns like the first 10 lines of the file, and that's what we see here. And then we can try looking at the PySpark program that we would run. The purpose of the demonstration, we would be running a k-means clustering algorithm. And the only thing that we have changed is the path to the file, which is mount point in this case. And we can run the PySpark code as you would normally do. And we can, let's just quickly wait. All right, so we see that the program is running, and now the program is almost finished. So this has been edited. It takes more time than what it shows, and the program runs and it terminates. So, and now let's try running the Spark program from Eclide. As usual, we would be starting the Hpcc fuse J with pass through Hpcc. And once we run that, and we use the same commands. And so the only difference is now we have to start the Livy server on the Spark cluster so that it starts up a server and it listens to the commands at, I think the port is 8998. And we see the Livy server as starting up. And now we can use our ECL IDE to run our code. So this is we are connected to the local to the Hpcc VM. And so this code is the exact same boilerplate code that we discussed in a previous slide. The only difference is the Spark code that we use is a k-means algorithm, and we need to be careful about the indentation. And as you can see, that took me quite some time to get this right. And we run, we use the run command, and we pass the IP and the code to the command to the embedded Python function. And all that you see is essentially the boilerplate code, which would remain the same throughout. And that's where we get our results, and we return the results, and that's pretty much it. And let's see if we can run this. So we hit a submit button. We can see that the Livy would accept that request, and if you see there's something going on the Livy terminal, and Livy terminal, and it would start like a Spark job. And all this time, the ECL, the Python Python code is essentially looking if the job is completed or not. Once the job is complete, we can essentially see our results on ECL IDE, and we see that we get some error, we get some results, and that's how this works. And Jessica can come back to the slides now. Get to that. All right, so let's move forward. So for future work, what we have seen is we are just talking about the functionality. We have never talked about performance. But if you are interested about the performance, you could visit this link, tiny.cc hpcc fuse j_perf. So the performance is not what we would expect, and that is because of the bottleneck that we have of HPCC Fuse J, because it takes something from a cluster, it has to go through one node, and then it needs to go back to the cluster. So essentially it is much slower than what we would ideally like. So our proposed change is to remove that bottleneck and have like a parallel transmission of data, transfer of data, and that is something that we want to do, and we expect that we should be able to do it by April next year. The other disadvantage of the current setup is we need to persist all our data before we actually execute Spark commands. So there should be, we think there should be a way to stream the data from HPCC system to Spark, and then we can get back the results from Spark. That is also something which we want to ideally do in April 2018. And this is pretty much what I did over the summer, and then that's all from the presentation. All right.
All right, Vivek, thank you so much. I'll give you a moment just to look at the question. And thank you so very much. This is definitely a topic that so many of us are very interested in. So we'll go ahead and get started with the question. So the first one here, do you have an estimation for the performance penalty of using HPCC Fuse J to access data on HPCC from Spark?
Right. The problem that we have with HPCC Fuse J, so what we do is we do not download the whole data onto the system. What we do is we get chunks of these data, and what happens is when you're doing something like this for a large data set, these add up, and it becomes like it becomes very performance heavy. And what we had seen in our results were like it is exponentially decays, the performance decays as the size of the file increases. I hope that answers the question. So in short, it's not, we would like it to be more fast.
All right, so definitely, I think that answers the question. All right, so our next question here, are there any limitations on the structure or type of the HPCC data that Spark can process?
So what currently HPCC Fuse J does, it only is only available for Thor files. So what we do is we have a sort of a process function which essentially converts, and to be more specific, HPCC Fuse J is only applicable for Thor files, and it converts and it exposes it as a JSON object. So what we do is in the Spark platform, what you need to do is you need to convert that HPCC Fuse J's JSON structure into something that is readable by Spark. So since we are exporting it as a JSON object, I think it can be used by Spark.
All right, perfect. Just taking a moment to look and see if any other questions have come in. All right, here's one. How does HPCC stand up to Spark in general, working with similar data? Just comparing each system separately, not the connectivity.
Yeah, this has nothing to do with the project that we're speaking, but we are doing something very similar where we are trying to do an apples-to-apples comparison between HPCC and Spark, and that is something that I'm working with Tim Humphrey to figure out, and I think we should have some results soon, and we would have like a comparison between these two systems. And I think that answers the question.
That's perfect, Vivek. I can certainly tell you that the marketing people are very interested in seeing the results of that. All right, so here's another question that came in. How does HPCC FuseJ allow a remote user command line access to data stored in an HPCC cluster?
So what it does is, Hpcc FuseJ is essentially like a Fuse plugin. What it does is, when you run it, what it essentially does is, on the mount point, whichever file system calls comes in, we essentially change that into web service calls, and which then goes and talks to the cluster, and it gets back the results. Like for example, if so we have like a caching mechanism in Hpcc FuseJ. What it does is, it would fetch, say for example, 300 records at a time and give it back. So we are essentially streaming the data from the Hpcc cluster onto the local machine. And yeah, and I hope that answers the question.
That's perfect. Vivek, thank you so much.
Oh, thank you.
All right. So we're going to go ahead and close out our event today. But for those of you who are interested in learning more about the Hpcc Systems Intern Program, Lorraine has provided us this wonderful page with all sorts of ways to reach out to it. And I think one of the things that is very important that I hope that you've gotten out of this presentation today is that this intern program is so very important to us. We take a lot of pride in the program, and we work very closely with our interns. I think Lorraine said it perfectly at the beginning of the presentation, is that our interns really become a member of our team, and we just take such pride in working with our interns, and we're so proud of the results that we've achieved. So many thanks to everyone for joining us today. Please consult the blog after the event, and we'll have an update there. We'll also have a link to this webcast so you can watch it after the fact. And if you are interested in submitting a talk for our upcoming episode, I believe our next one is in the middle of September, around the 14th, and we would love to have you be a presenter. So please just reach out to us and let us know if you're interested. And please also check out the HPCC Systems Community Day that's coming up. Thank you so much.